Hello everyone. I am Chris from the Lazily Vietnam Maintenance Service Team. So what are we talking about today? Rack settlement in AS/RES systems. Many of you may feel rack settlement is far removed from your daily work. But pay attention, it is actually the most fundamental factor affecting AS/RES running accuracy. If the foundation is unstable, everything else is reset to zero. In this episode, we'll systematically walk through settlement monitoring methods and adjustment solutions. In this episode, we'll nail down 4 things. First, why racks settle. Second, how to monitor it. Third, at what point settlement is out of tolerance. Fourth, how to adjust and repair. In other words, once the foundation has a problem, even the best stacker crane is useless. Think about it, AS/RES racks hold loads of several or even tens of tons. Once the ground settles, the rack tilts, the aisle narrows, and the stacker running back and forth easily collides. What's most dangerous? Settlement happens slowly. You can't notice it at first. And by the time the problem shows up, the repair cost is already very high. So an unstable foundation resets everything to zero. There are 5 main causes of settlement. What's number 1? Subsoil problems. Especially here in Vietnam, many plants are built on soft soil. Foundation versus problems are bound to appear over time. Second is inadequate foundation design with insufficient bearing capacity. Third is overloading during operation. Too much, too heavy. The floor itself can also sink. Finally, environmental changes such as groundwater fluctuation or nearby construction. So how do we set monitoring points? Remember a few key things. Points go at the base of rack columns, both ends and the middle of the aisle, and especially at corners. Place one every 10-15 amp along the rack. Also set at least 3 benchmarks outside the warehouse, driven down to a stable stratum below 5. And one crucial thing, measure the initial value right after rack installation. That data is your baseline for all future comparison. There are several ways to measure settlement. The most common is precise leveling, accurate to 0.3 mm/km, and it's more economical than a total station or hydrostatic system. With more budget, install hydrostatic levels in key areas for real-time online monitoring straight to the computer. Laser scanning is very intuitive, but the equipment is expensive and data processing is troublesome, good for full surveys. For routine monitoring, precise leveling is enough. You may ask which one is best. It depends on your budget and accuracy requirements. Recording settlement data isn't enough. The key is to analyze it. Here we've built a 3-level alert system. Yellow means cumulative settlement over 10 millimeters. Increase monitoring frequency. Orange means over 20 millimeters, start planning the adjustment. Red means over 30 millimeter, or a difference of more than 15 millimeter between 2 adjacent columns. You must stop immediately and do a full inspection. Let me stress this: differential settlement is more dangerous than cumulative settlement. Why? Because differential settlement directly tilts the rack and narrows the aisle. This table lists reference standards for rack installation acceptance. Focus on 3 numbers. First, column verticality deviation must not exceed H1000, where H is the rack height, at most 15 millimeters. Second, aisle width deviation must stay within +5 mm. Third, differential settlement must not exceed L400, where L is the spacing between adjacent columns. Again, at most 15 millimeters. A simple rule of thumb: when differential settlement exceeds 10 millimeters, start paying attention. Over 15 millimeter, you must adjust immediately. If differential settlement is within 20 millimeter, the foundation is undamaged, and settlement has stabilized. The simplest fix is shim adjustment. I note, you must use stainless steel shims. Huma-fode wood or rubber, which deform over time. Use at most 3 shims per column, total thickness no more than 5 millimeters. Always unload before you start. Lift slowly with a jack, no more than 3 millimeters per lift. If shimming can't fix it, and say differential settlement exceeds 20 millimeters or the foundation itself has cracked, you need foundation repair. There are three options by damage level. Minor sinking can be reinforced by grouting, injecting slurry under the foundation to fill voids. Insufficient bearing capacity calls for enlarging around the existing base. If the foundation is severely damaged, the only option is to demolish and recast. Whichever option, it must be carried out by a professional contractor. Floor repair has four options: grout local sinking, overlay a concrete layer where it's generally low, demolish and repour where severely damaged, and add an epoxy floor where cleanliness matters. After adjustment, don't cut corners on acceptance testing. A second, remeasure rack levelness, remeasure aisle width, and run the stacker first under no load, then under full load. And in the first year after adjustment, keep monitoring at 1 week, 1 month, 3 months, 6 months, and 12 months. Having covered repair, let's talk prevention. During construction, do thorough geological survey and ground treatment. Soft soil in particular must be reinforced. During operation, control the load, avoid overloading, and do regular settlement surveys. Here's an experience figure. Prevention costs only 1/5 to 1/10 of repair. So rather than spending big money fixing problems later, do your monitoring well day to day. Finally, a real case. At one SSRS, after 3 years of service, the stacker kept alarming on collisions. At first everyone assumed it was the stacker, but after long inspection the equipment was fine. Then they measured the aisle width and found the midsection had narrowed by 12 mm. Digging deeper, 2 columns had a differential settlement of 14 millimeters. Note this, cumulative settlement in that area had already reached 22 millimeter, past the orange alert line. But because nobody looked at the data, it was never addressed. The lesson: don't judge settlement data by absolute value alone. Differential settlement is the key. Let's recap today's key content. 6 points. First, differential settlement matters more than cumulative. Second, place monitoring points scientifically. Third, use the 3-level alert system well. So, don't wait for trouble. Fourth, fix small problems with shims. Fifth, get professionals for foundation repair on big problems. Sixth, prevention is far cheaper than repair. Remember, one line and unstable foundation resets everything to zero. That's it for this episode. We went through the causes of rack settlement, how to monitor it, how to judge severity, and how to adjust and repair. Next episode we'll talk about stacker rail wear. The rail is the stacker's running track, and once it wears the stacker shakes and drifts, with a big impact. Finally, let me sneak in a little ad, if you don't mind. Feel free to take note. Our Lazili Vietnam team specializes in local logistics automation equipment maintenance in Vietnam. We are a fully professional local service team, available on call anytime. If you have equipment maintenance needs, bosses are welcome to reach out to us. Thanks everyone. See you next time.